This video will walk you through a design strategy when laying out a wraparound heat pipe for your DOAS unit that's delivering neutral air. Now, I went ahead and created a project called Grand Hotel, which is located in Orlando, Florida. Now, this particular DOAS unit is delivering air to a hallway space where you have little sensible load. So instead of delivering air at 50 to 55 degrees saturated, you're adding some sort of reheat so that you're delivering air that's at the neutral condition between 70 to 75 degrees, which is where the wraparound heat pipe comes in, because you could potentially supplement to even remove the amount of reheat that you need to do with your air handler, thus saving you energy. So let's jump right into your selection by hitting the Select Item button. At the input screen, I went ahead and pre-filled some of the inputs. The only thing I changed was the fin height and fin length, which I typed in 35 and 50, airflow of 5,000 CFMs, 9176 entering, and I'm leaving my cooling coil at 5554. I kept the default as a number of rows of 2, and I kept it as a standard non-controllable, which we'll get into later. Let's go ahead and click Calculate and see what happens. And you can see I'm leaving my reheat heat pipe at 66.4. What I'm looking for is a reheat condition of 70 degrees. So let's go ahead and click Reselect and change this to a 3-row. And click Calculate. Now when I hit Calculate, now I'm leaving my reheat heat pipe at 69.8, which is sufficient in this case. Now, what I want to look at is what happens at various temperature conditions. Now to view that, go ahead and click your economic analysis. To load your economic analysis, go ahead and choose your location, which is Orlando, Florida. Hit Apply. Now I'm going to assume this runs for 24/7, so I'm going to keep the occupied hour runtime as the default. So let's go ahead and load our weather bin data and click Duplicate Row. Now to calculate the economic analysis, just click Calculate. And here is my savings screen. So you could say that the heat pipe energy savings is $9,466. I'm assuming electric rate of 8 cents, and I'm assuming electric reheat as well. So let's go ahead and hit continue, and let's actually look at specific bin rows. Click Save and Close. At the project schedule screen, I went ahead and outputted the report for bin analysis for Orlando, Florida. Let me go ahead and open this. And here you could see the savings analysis with the outside air, pre-cool heat pipe, as well as the reheat heat pipe. Now examining the top 2 rows, I'm hitting the neutral air condition that I'm looking for. However, for temperatures below 87.7 degrees outside air, I'm going to need to start using some sort of supplemental reheat to get back to that neutral air condition. Now one thing you could do is to increase the number of hours in which you hit the 70-degree set point that you're looking for, is essentially over-design your heat pipe. So what you can do is go up to a 6-row heat pipe in which you have more rows hitting 70 degrees at your part load conditions. However, at your design conditions, you're going to be exceeding your 70 degree. However, to counter that, we do offer a controllable heat pipe in which you're able to modulate the performance at the rows in which you exceed the 70-degree set point that you're looking for. So let's go ahead and do that and see what happens. Now let's jump back into our selections and make the changes by clicking the Select Item button, changing the number of rows from 3 to 6. Let's go ahead and increase the fins per inch as well from 12 to 14. And like I said, let's make this controllable because at the design conditions, we will be exceeding the 70-degree neutral air set point that we're looking for. So let's go ahead and click Calculate. And as expected, we're exceeding 70 degrees or close to 74. Now let's go ahead and run the economic analysis so we can see what happens at part load. So let's go ahead and click Calculate. Hit Continue. And Save and Close. Now I went ahead and outputted an economic analysis report for the 6-row controllable we just selected. So when I open that up and scroll down to the reheat heat pipe section, you could see that I hit the 70-degree set point at more weather bin rows. I'm starting to get more recovery at the part load conditions. The previous 3-row non-controllable selection, I was only hitting 70 degrees at the design conditions. Now, since this is controllable, I exceed 70 degrees, but since I do have control valves, I could stage back the performance to get back to the 70-degree neutral air that I'm looking for. So in regards to hours, out of the 8,000 cooling hours in Orlando, Florida, the 6-row controllable needs 0 extra reheat for about 2,000 hours out of the year, whereas a 3-row non-controllable, it used zero reheat for about 138 hours out of the year, which is what the design condition was. In addition, the 6-row controllable, you are recovering more BTUs upstream as well with the pre-cool heat pipe. So not only are you recovering more BTUs on the reheat side at part load conditions, you are recovering more BTUs upstream with your pre-cool heat pipe as well. Thank you for taking the time to watch this video. I encourage you to check out the other videos on this channel. Have a wonderful day.